Hey guys, welcome to my channel again. And again we have a graphics card on the table. What is it? That's RTX 2060 Super from Palit, 8 GB version. I mean, that's the amount of RAM this model has. So it's actually upgrade compared to 2060, which was only 6 GB, and this is closer to 2070 to be honest, and 8 GB is still a decent amount of RAM these days. So yeah, quite a nice card. Let me open it. Let's get rid of the box. One box. So okay, we have the box here, another box, and there's a card, some foam for protection, and that's our card right here. So let me take it out as well, remove this. Okay, so we have a card on the table. Let's have a look at first. So that's Palit. Doesn't look super premium, I would say. The shroud is plastic and like transparent. It feels very plasticky to be honest. It also has a back plate, but yeah, it's also plastic, so it doesn't help with the cooling of the card. Yeah, well, I mean, so, but at least it protects the back of the card, so that's actually useful, especially like for those capacitors that are hidden somewhere here. They can get easily knocked off by accident when installing the graphics card or uninstalling. So overall, I think the backplate is a good idea. But looking at the heatsink, I would say it's pretty solid. I mean, the weight of it and the size and basically how it makes contact to the card. So it's not only held by those 4 screws that actually hold the heatsink, but it's also it has multiple screws all over the card, so actually the pressure and the contact with the PCB is actually pretty good, seems to be pretty good. So not sure if you can see it well. Okay, so it's actually pretty good, I would say. So I imagine the cooling may be quite good. So what do we do with the card? So it's still assembled, and as you can see it has a warranty sticker, so it hasn't been opened before, looks like. So that's always good news, because if someone worked on it and failed, then it may be even worse than it was. So yeah, let's have a look at the card. Let's quickly check the resistances before we disassemble the card. So just quickly check the main voltages. Okay, so ground on the metal backplate, and third pin, I mean those 3 pins at the beginning for 12 volts. I'm not sure if you can see the multimeter. You cannot see the multimeter. Let me move it a bit. Now you see it. Okay, let me get the ground here. Okay, so the first 3 pins, and we have over 1 mega ohm. That's perfect. So it's like with the previous video where the fuse was blown, so there was no reading on 12 volts. Here it is. So that means the fuse you can see here, small white one here, is probably good. And just to double check that, but I'm sure it is, let me, okay, so almost 0 ohms, so that's good. So the fuse is good. Also let's check 3 volts, so the 4th pin from the notch on this part. 1, 2, 3, 4. and we have kilo ohms. That's perfectly fine. So then we check the 12 volts from the PCI Express slot, sorry, from the connector. So we have ohms and rising to mega ohms, kilo ohms basically. So all good here for the 8 pin, good, and here also fine. Okay, so that's good. Means we don't have any short. We can also check in the diode mode, just in case, like check the at least 1 or 2 pairs if there's no short. 73.73. The second one is probably this one, 0.73, that's fine. And the last one should be this one here. It's 0.73 and 0.73, so that's good. To make more measurements, probably we need to disassemble the card. I mean, I can hold it like this, and I can see the coils here, so actually I can measure the coils right here, and it measures what? Oh, sorry, not in the diode mode, in the ohms mode. 11.9 ohms, so that's probably PEX, and this seems fine. And there's another coil here, which is in kilo ohms, if I measure correctly. It's quite difficult to reach here, but let's double check. Yeah, it's in kilo ohms, so that's also good. That may be, I don't know, 1.8 or 5 volts, I'm not sure. But the rest of the coils I cannot access from here, so this is where I will pause the video, and we see each other after I disassemble the card. Okay, so I have a card disassembled in front of me. Let's do some measurements. Let me turn on the multimeter. So we already checked the 12 volts and the 3.3 volts here, but we can double check. So the fuse is good again here, and there should be continuity from 12 volts to this coil, which is 12 volts as well, and there is. And also here we have one fuse on 12 volts from the PSU, and that's also almost 0, so that's perfectly fine. The fuse is good. Let's carry on with the measurements. So let me check. Actually, it's a difficult measurement actually to check the core, because as I mentioned last time, it usually has a lot low resistance. But so the resistance of the probes is around 0.73, 74. So everything higher than that should be fine on the core. So let's check this coil here. 0.93, so 0.2 of an ohm difference. So I would say this may be fine. Again, 0.92. Let's check on this side, maybe will be easier. Here it's even higher, or maybe I don't have good contact to measure properly. Okay, it's going down. Yeah, it's the same. So I suppose all of them are the same, and I would say that's giving hope for a good GPU. At least it doesn't look shorted. Then we can check. Here we have a BIOS chip. Not sure if you can see it, but just behind this capacitor here we have a BIOS chip, and on the leg number 8, which is the power to the BIOS chip, we have kilo ohms, so that's great. So it's also some kind of confirmation that the core may be okay. Then we have coil here, which I think we checked it. Oh, sorry, there is one here. So that's, I believe that's 5 volts coil and it's in kilo ohms. That's fine. Then we have the coil here, and I think we checked it already, but let's do it again. So we have 11.4, that's probably pegs, and that's fine. So I would guess that's 1.8. Let's see what's the resistance here. In kilo ohms as well, so that looks fine to me. What else? So here we have two coils and one here, but different type of coils. So like yeah, different types. So there are terminals on the other side of the card. Of course, we could measure something here as well. So that's probably the input MOSFETs here. So high side MOSFETs, and those are low side MOSFETs. So here comes the voltage here. I mean, we're in the resistance mode, but the voltage comes here, then goes here, here, and that goes to ground. So we could measure either here or here. So actually, let's do that. Let's check the resistance here after the first MOSFET. Oh, and it's 10 ohms. It's 10 ohms, and the memory we have here, not sure if you can see it, probably not, but you have to trust me, it's micron memory. I would say that's way too low for micron. I would expect for Samsung, which is usually low, like around 20-25 ohms, and for micron I would expect something like 40 at least. So that's right, that's wrong right there. Let's confirm that. So we have those coils here and here. Let's flip the card. So let's double check on the memory coils here, and we have, yeah, 10 ohms, so it's the same. And here we have the coil, that's probably 12 volts from the PCI Express slot, and it's rising into kilo ohms, mega ohms even, so something in kilo ohms. It's perfectly fine, and so it's probably connected. So here's 12 volts going through the fuse. We have a continuity here. Yes, we have. There's a shunt resistor. Oh, sorry. And we have a continuity here as well. And probably it's going to this coil, so that's fine. So, I mean, let me check a few more things, but looks like we have a problem with the memory, or possibly a core as well, because if the memory is shorted, then it's very likely that the CPU was shorted as well. Alright, let me switch to the diode mode and let's check the PEX reset. And that's 0.7, looks okay to me. And then the second and the third pin here, which is reference clock, that's 0.82. And the other one is 0.82, so that's fine. And are they shorted together? No, they are not, so that's good. Then last thing we can check is the voltage drop on those capacitors on the card side. So 0.8, 0.8. Let's just check some random. 0.8, 0.8, 0.8. 0.8. So this is a bit lower, is it? No, it's okay. I just didn't press well enough. So looks like all of them are fine. I would need to check all of them, but looks fine to me. Okay, so with that, what we're gonna do, I would try voltage injection and see what gets hot. So I will probably inject on this side of the board, so probably here after the first MOSFET, and I will inject something like 0.9 volt. That should be safe both for core, or 0.8 should be safe for the core, but should also be, it is perfectly safe for the memories, because memories operate at 1.2, I believe. Unfortunately, my thermal camera needs to be attached to the phone, so I won't be able to record. So I will probably make a video from the thermal camera and show you that in the video. I'll edit the video and then put that part from that thermal camera there as well. So see you guys in the next part. Okay, so small change of plans. There will be no thermal camera footage because it's simply not needed. So I did it off camera actually. I did inject the voltage to, well, here to those MOSFETs. You could do it in a few places, but that's one of the possibilities. So I did inject the voltage, and I injected first 0.9 volt, which is quite safe voltage. And I noticed that those two resistors here, not sure if you can see it, it's probably pretty small, but it's there, here, those two, were getting warm a bit. When I increased the voltage to 1.2 volt, all the memory modules also started to get slightly warm, but it didn't look like a short, to be honest. And well, I was still a bit confused why I have around 10 ohms on memory, because as I said, it seemed too low. Also, the design of this card is very weird, because those resistors I mentioned, it's strange because on the PCB it says C1160 and C1163, which would indicate a capacitor, but instead of capacitor they put resistors, 22 ohm resistors here. And if you look a bit up here, you have also some components marked as capacitors, but they actually are capacitors. Like between those aluminum caps you have the small ceramic caps. So that's very weird. I thought maybe someone opened the card before, but as you've seen at the beginning, the card had a factory seal and it didn't look like someone was inside before me, so that's super strange. But then I found a video from Buildzoid. I will link it in the video description, and he had pretty much the same card. It's the same manufacturer, just different brand. So Palit is the same manufacturer as Gainward, I think. So it's Expert Vision, I think, or something like this. Anyway, so they basically use the same board, the same layout, just change the cooling system, the shroud, so it looks different. And he actually explained how he repaired his card. The fault was different to mine, so he had some issues with the 5 volts here missing, so all the other voltages were missing as well. Anyway, you can watch it if you want. But the point is, what he said, he was showing the measurements on all the coils and all the critical areas here, and what he also noticed was exactly the same I had, so very low resistance on the memory, and he said it's fine. So around 10 ohms, and even PEX was like 11 ohms, so having memory with lower resistance than PEX is very unusual, I would say, but well, you learn something new every day, so there is a chance that actually the memory may be fine as well. But then we checked everything and there's nothing wrong with the card. No shorts, no burned fuses, nothing. Like, everything seems okay. So the only thing that comes to my mind is reflashing the BIOS, and there's another small problem here. So I mean, it's not a big problem, but the BIOS chip is here. Not sure if you can see it well. It's here. Maybe I'll use the pointer. So here's the BIOS chip, and so of course I could apply some leaded solder to decrease the melting temperature and then try to desolder it, But first of all, I'm lazy and I don't like to desolder BIOS chips. I mean, you have to desolder it, solder it to the mm, programmer board, or use some kind of adapter and then solder it back after reprogramming. So I prefer to use a clip, but well, there's another problem. So even for using hot air, it's quite, well, maybe not dangerous, but it's dangerous for the card, because if I apply heat here, this aluminum cap can explode as well. So you have to either shield it somehow and be careful, but yeah, it's always risky. There's always risk that it's gonna pop. So and with the clip I'm using, usually it's this one. That's the one I have from like very beginning. The problem with that, it's a bit wider than the clip itself, like the tip of the clip. So basically, if I try to attach it, this aluminum capacitor is blocking, so I cannot align all the pins. Like I'm like 1 or 2 pins to the right, so I cannot cover all the pins exactly and align the clip with the BIOS chip. Luckily, like just day after I decided to do it, I got this, and actually I tried off camera as well, and so it's called pogo pins. It's basically, I will cover it maybe in a short on my channel, but it's a set of pins that actually are like spring mounted, and they like move a little bit here, and they have like, you can't see it here, you can see it under the microscope. It has like sharp edges here, but anyway, what it does, it's more narrow than the other clip. So actually I was able to just, you know, align the pins and then push a little bit down, and that's with one hand, and with the other hand I use the application to program the chip. I downloaded the latest BIOS, or not the latest, working BIOS from the TechPowerUp website, and I was able to program the chip. It's 1 megabyte, so it runs really quick. So I actually did program the BIOS chip already. Yeah, so let's put the card on the test bench and see if it works. That's my last idea, I would say. At the moment I don't have any more clues, so if it doesn't work, then well, we'll see. Actually, a small disclaimer, so I didn't program the BIOS straight after measuring the resistances. Of course, I connected the card to my test bench and I measured the voltages. So FYI, all the voltages are present: 5 volts, PEX 1 volt, 1.8, and the memory 1.35, I think it is. So all the voltages and 12 volts, of course, 3.3, everything is present. But the card still doesn't give a picture, so that's why I decided to reprogram the BIOS. Okay, so I have the card in front of me, attached to my test bench. Everything's connected. I slapped the hefty cooler on top of the card, and it's actually, the fan on it will actually spin because it's connected to the motherboard, and we have a pen drive just in case with the memory testing tool. So the card is after BIOS update, after using programmer, so I reprogrammed the BIOS with the one found on TechPowerUp, and let's see if it gives a picture, and if it does, then the memory test will also run. Let's see how it goes. I have a power button here. Let's press it. Oh, sorry, no power. Now let's press it again. Oh, it's spinning. Do we have a picture? Looks like, yep, we have a picture. What's next? Linux is loading. Can I focus? Okay. Linux is loading. Memory test is running. Do we have any errors? Looks okay. There's no artifacts, no glitches. This is normal, to be precise. So looking at this based on my experience, I think it looks promising. But let's wait till the end. Okay, and we have a pass, so the memory modules seem to be fine. And the computer switched off. That's how I configured the application to shut down after running. That's great. So the card has been running for an hour now. As you can see, it's running, it's on, and it was running full mark for exactly an hour, you can see here. And what do we have? So the clocks look good. GPU temperature is 73 degrees and hotspot 86 degrees, which is fine for this type of card and cooler. And the delta is also healthy. 13 degrees difference between the core and hotspot is also perfectly fine. Let's check maybe the card info. RTX 2060 Super. You have the amount of RAM and everything. All the parameters are as expected. Everything is populated, so I will leave the card running for a few more hours just to stress test it and make sure it's fine, but as you can see, everything works and it's good to go.